go there. No, yeah. Problem is that I don't like all these things. No, marriage, that's okay, see. But hey, you are sharing your screen, Acha. If parents means you like mother, father, sister, brother, that's okay. But whatever the others don't. You gave it like that? You gave it as sorry? You? Okay, yes.
Hi, I'm Karthik and Rannan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it. Thank you.
Yeah, hello everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT Bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be high placed in that company. I'm confident about that. Thank you.
Hello everyone. So we'll start in next 2 to 3 minutes. So I request everyone to join in fast. So no one will miss the session today. Today is gonna be very interesting. So we'll start in 2 3 minutes. Please join fast. Okay. I can see still people are joining, so I request everyone to join in fast so that we can start the session at earliest. So guys, today's agenda, first we'll go through the code for the CNN, and then we'll try to start on the chat GPT generative AI topics. All right. And end of it, I would like to take one. We'll try to have some hands-on chat GPT, like we listed some use cases. I'll try to focus more on the more part of the prompt engineering today. We'll try to understand prompt engineering. We'll try to run few prompts. How can we generate an entire model using the prompts? We'll try to take some data, financial data as well as the diabetic data. That's we'll try to run. And I will give you small overview of the transformer architecture. So that's the plan. And in end of it, I'll try to showcase you one application, how we can create an app using generative AI. All right. So before we begin, just give me 1 minute. So I can start sharing my screen. Just a moment, and that's it. We'll start. Guys, just give me confirmation you're able to hear me properly. And once I share my screen, so we can start. Just a moment, guys. Give me 1 minute, and we can start. Right, it's slow. Give it a minute. Okay. Just 1 minute, guys, and we can start. The computer seems to be very slow today. Just give me 1 more minute. It's loading the collab notebook, and I will start sharing it. All right, here we go. Let me know once you are able to see my screen. Just comment in the chat box and we can start then. All right. Is it visible, guys? Can you ping me? Not yet, I guess. You know why it's so slow today. Okay. So guys, please confirm me. Now I think you should be able to see my screen. Yeah, thank you, Murish Kamling. Yes. Few more confirmation, guys, and we can start. Please confirm. Yeah, thank you, thank you, thank you, guys. So let's get started. So we started seeing all the convolution operation, how the convolution operation happens, what are the three architecture of the convolution, entire architecture look like, and how can we build our own architecture. That's what we're going to see today. So we'll try to build simple convolution neural network, our own architecture, and very, very simple. We'll try to keep it three layers only. And we'll try to do a bifurcation, binary class bifurcation. And let's see what we're going to build today first. So obviously we're going to take only two binary classes. One is dog and cat, and we'll try to download these images and try to build this application out here. So for that reason, so let's go down first and let's try to see how the architecture will look like, what the architecture will be building today. No, it's not allowing, it's getting hang again and again. Just a minute. Okay. So just 1 minute, we'll scroll down. It's usually getting hanging. I don't know why. Oh, okay. It's very slow. I just wanted to showcase you first that what is architecture. Now it's moving somehow. Okay. All right. So this is the architecture we'll be building. Okay. Let's try to understand, guys. What is the architecture we're gonna build first, and then we'll try to understand how to run this code, right? So the model will be using sequential only first. So what we're gonna do is we'll try to create our first convolution layer out here. All right. So convolution layer will be using first, convolution 2D layer will be using, and then followed by the, you can say that there will be batch normalization, there will be max pooling, and then one more convolution layer will be using. All right. So one convolution layer, conv1, then we'll have convolution layer 2, and then followed in between, we'll try to keep it the batch normalization. Okay. Batch normalization layer and pooling layer will also be associated with it, the pooling operation, and then we'll have a second convolution operation, then followed by the batch normalization, max pooling, and there will be convolution layer thing. Okay. So this is how the convolution will look like, and then followed by the ANN, our feed forward network, which will help us to understand. And in the end, we'll have a single neuron, which will be able to give us the bifurcation, whether it's a dog or cat, right? So this is what we're going to build. And let's have a look that how many parameters it will be generating for that reason. Okay. So in total, we can see it's very slow. What's wrong? Yeah. So you can see here, we will be creating total 14 lakh parameters, right? So this is what that architecture will look like. You can see now, imagine that how big this neural network gonna be convolution when we try to convolute this rate. So we are using 3 convolution layer, and then followed by 1 flatten layer. You can see here, and then there will be a dense layer 1, dense layer 2, and this is how the last dense layer will look like out of the single neuron, right? So this flatten layer, we are not going to pass any dimension. It will try to take the dimension based on the feature it is trying to extract in the previous layer, and then followed by our normal 128 neuron, 120 neuron, 64, and then the followed by the 1. Okay. This is what the architecture will look like. Let's go try to begin. How we'll try to load this data and how the architecture will look like. Okay. So for that reason, guys, this is the dataset link which we'll be using from the Kaggle dataset, doccat dataset. And what I'm going to do is this command mkdir, what it will try to do is it will try to create one directory out here called as Kaggle. And within that directory, we'll try to download this dataset from the Kaggle. Okay, this command. So you will be able to see one directory here. So the moment we try to run this, we'll be able to see one directory here. And within that directory, we'll try to download our data file, right? So first, this command will try to create the directory here, and we will go inside that directory, and inside that directory, this command will help us to download the dataset directly from the Kaggle. Okay. Now you can see I already downloaded the dataset. I won't download it again. So you can see here, you will be able to see the progress, and this will be a zip file. Since it is a zip file, we'll try to unzip that file by using the command. Okay, zip file dot zip file, and then we have to provide the path for the Google Drive. So content, and within that content, we have created this, right, path and doccat.zip, right? So once we are able to give it, it will be able to extract and it will try to keep it the entire files out here, right? And once we keep the file, now you know the drill. So first we'll start with importing the files, importing the libraries. So first in the background, we'll be using TensorFlow, followed by the Keras, and model gonna be the same way, sequential, right? So model will be using same. Now the layers will be different as of now, right? So in artificial neural network, we have seen we are using dense layer, we are using flattened layer, as well as the batch normalization layer and dropout layer. This layer we already seen. Now what will happen is we are using these two extra layers. One is called as convolution 2D and max pooling 2D. We can use 2D or 3D layers as well, right? So for that reason, what we're going to do is, in order to perform the convolution, we'll be using two layers of the convolution, and after every convolution, we'll try to have a padding and as well as a pooling as well, right? All three operation will happen, and one more time we'll try to run this convolution operation, right? So for that reason, we are importing these layers: convolution 2D, max pooling, flatten layer, just to flatten all our features and feed it to our feed forward network. All right. So now, first thing which I am going to create is the generators. Now, what are the generator? Generator are simply trying to create one path to the directory where you're saving all your data, right? So since we have created two path here, one generator will be for training. So keras.utilities.image.dataset from the directory. This is the function, right? So by using this, we are trying to create one generator. Generator will be training dataset generator. So we are just trying to provide the path, the labels. Labels is inferred label, means whatever the labels we have given to the picture, so the same label will be taken, and the label mode will be int, and the batch size will be 32. In the batch of 32, will be passing this, right? So to the data loader, and then the size of our image is 256 by 256, right? The same way we have created this trainer for the training data set. So same way we'll have to create for the test data set as well, right? So for the test data set, validation data set, same function, keras utilities image data set from directory. The labels will be inferred, batch size will be 32, and the image size will be 256 by 256. And this is the path for the Google Drive, which the folder we created and stored our files. All right. Guys, once I am able to load this file, right? So you can see it has found 20,000 images for the training purpose. So 10,000 images of the cat, 10,000 images of the dog. Maybe I will try to showcase you this if I have opened here. I'm not sure if I kept it here. Okay. So let me show you. This is the IRID data set. How the data set will look like. We'll try to see this one. Somewhere here I kept the data set. No, this one is different. So let's search this dog and cat data set, and I will try to showcase you what the data set look like. Okay. That data set. Let's go inside this data set and I'll walk you through how the images will look like. And we'll try to see the images, like how the images look like for this one. We are having 20,000 images in total. So out of that 20,000 images, 10,000 images for the dog and 10,000 images for the cat, right? So this is what it will look like. All right. Okay, you guys can see here test and train file. And within the test and train, we will be able to find the data set. So it is not showing the data set as now, it is showing the zip file, but you can see there will be 10,000 images for dog and 10,000 images for cat, right? So you can go and download this data set. It's showing zip file. So this way you will be able to find out. So we'll skip as of now, but it is taking some time to load this data set. And once we have this data set train and test 10,000 images each, Okay, so you said you cannot handle the CNN. Yeah, CNN handle means guys, it is for the training purpose. See, it is just the simple training we are trying to do, right? When you're trying to actually train the entire big data set, that time your GPU will get disconnected. That's the reason I said you will not be able to handle it in the collab, right? So this is the simple architecture we are trying to run, and our epochs are not that great. That's the reason you will be able to see it. But otherwise, if you're trying to run a project, big project for let's say 50,000 epochs, 1 lakh, at that time you will get disconnected. That's the issue, right? So if you get disconnected, that will be the problem. Then again, you will have to start the connection and you have to save the checkpoints and all. So that's the reason also. Okay. So once we are able to load the data set, guys, you can see 20,000 images are there for 2 classes and 5,000 images we have kept for the testing purpose, right? So once I take the images, guys, I am trying to take these images, convert into the matrices, and then I am trying to normalize them by using image divided by 255. Okay. So once we normalize this data set, now we can start building our model. All right. So how to build the model? Same. First, I'm going to call my sequential model. And within that sequential model, I'll be using now, we can see here, we are using, this is convolution layer 1, this is convolution layer 2, and this is convolution layer 3. So 3 times we'll try to convolute the pictures. All right. So this is how the blocks are there. And every block will have convolution. Then there you can see there is a padding and pooling layer as well, and the batch normalization. Okay. So everywhere just copy paste the same code and we'll try to understand everything. It will be same. So let's try to understand. First, I'm tracking the convolution block like this one. So within this convolution block also, we are doing this convolution 3 times, conv1, conv2, and conv3. Okay. And within that convolution, we'll be having all the convolution operation, padding operation, and pooling operation everywhere, all the 3 operations. All right. So this is what we are trying to create here. So model.add convolution 2D. So I am adding 32 kernels. Okay. You can see here this 32 means this is the kernel size of 3 by 3. So such 32 kernels I am adding. Then followed by the padding, valid equal to valid means it will try to take the padding as same. Then followed by the activation function, we are taking activation function as ReLU. And first time you have to just give the input size and that's it, only for the first time. So input dimension will be the size of our images, what you are trying to take. So it is a color image and it is 256 by 256. That's the size of the image, right? So that's what we have taken here. Then once we are able to give this activation function, padding will be clubbed with the convolution, and we are applying 32 kernels of size 3, 3, right? So this will be the 3, 3 matrices which we will be taking here, and such 32 kernels we will be applying on the images, right? So try to understand. That's why you see the reason that we are able to generate 14 lakh of the parameters, right? Because of this. And then we'll try to add the normalization layer and then followed by the max pooling, right? Max pooling 2D. Again, the max pooling will be having 2, 2 size of the pooling size matrices. Stride we are taking 2 as of now, and padding equal to valid means try to do a padding once we are trying to do a max pooling as well, right? So the same thing. So this will be our first convolution block. Okay, same thing we have copy pasted here because we want to do convolution at the 3 times. So model.add. Now this time only change what we're trying to do is once we are able to extract the features, out of that features, we are going to extract many features. We want to go into the deep dive into the minute level of the features. That reason I am just changing the kernel size, right? Number of kernels I am changing. The size of the kernel is same 3, 3. But at the convolution layer 2, I am trying to take 64 kernels, and at convolution layer 3, I am taking 128 kernels. All right. Rest everything is gonna be same, max pooling and the batch normalization followed by that. And once I try to perform this 3 level the convolution, so whatever the images I will be getting, whatever the features from the images I'll be getting, I'll try to store them into flattening layer, right? So once I do the flattening, then I can pass this flattening information to my feed forward network, all right? So in the feed forward network, first I'm going to add the dense layer and the activation function as ReLU, okay? So guys, I am not taking sigmoid anywhere because we know that if we try to take the sigmoid, we'll try to face the same issue of vanishing and exploding gradient problems, right? Especially the vanishing. Exploding will come due to the many derivatives we are trying to take out here, right? So once I am trying to take this one dense layer, first dense layer, which will be our input layer, then I am trying to add a dropout layer as well. So what I'm trying to say is you try to initially don't use this dropout layer. Okay, so go without the dropout layer first, and then if you are able to see that there is a overfitting or you are not able to get the correct what you can say, correct accuracy, then maybe you can try this one, right? So let me grab this thing and let's try to understand what will be the next architecture. Once we add this input layer, then there will be one hidden layer out here. In the hidden layer, we are taking 64 neurons and then followed by the one single neuron in the output layer. And here I am taking sigmoid activation function since I am using the binary class classification. All right. So this is how our entire architecture look like. So just to draw it once again. So there will be this architecture, right? So this is input layer. In input layer, I am having 128 neuron, followed by the hidden layer, 68 neuron, sorry, 64 neuron. And this is my output layer, which will be having one single neuron. And prior to that, I will have a convolution block here, conv block. And this conv block, okay, conv block will have a 3 level of convolution, convolution 1, convolution 2, and convolution 3, right? So 3 times we are going to use. So first time I am using 32 kernels. Second time I am using 64 kernels. Third time I am using 128 kernels. And the kernel size is going to be same 3 by 3 everywhere, right? All of them. So 3 by 3 is the matrix size or the kernel size which I am using. And I am trying to increase at every level. That the moment I am trying to go to the level 1, level 2, level 3 deeper, I am trying to increase my kernels, right? So third time I am using 128 kernels. So this is what the entire architecture we have created here. Since our why I am trying to create, because if you would have seen this data set, here we are trying to take all category, all the breeds of the dogs and all the breeds of the cats. So that's the reason our model should be able to understand, and with the different lighting condition and with the human, with the multiple images available, right? So I am not able to show you the image, otherwise you have seen that image, right? So this zip file, if you try to search that, you will find out this 10,000 images for dog and 10,000 images for the cat. All of them are having different lighting condition, different breeds of the dog and different cats, right? So that's the reason we're trying to go deep dive. So my kernels will be able to understand each and every minute detail, right? So once I am able to do it, I will try to see my summary. The summary looks like this one. So you can see for fourth convolution block, it is creating 896 parameters. All right. Yeah, guys, data augmentation is always, it is always the preferred method, Hari sir. So when we have a less data, see, in our case, we are able to manage 20,000 images. But in reality, when you're trying to use this kind of a thing for any usual business case, you will not have a privilege to use this many use cases, right? This many, sorry, images as an input. That's the reason we'll be using augmentation technique at that time, right? So you can see that augmentation techniques works very well. What about unbalanced data? Unbalanced data will not matter here, because what is going to happen is anyhow we are trying to extract the features, right? Unbalanced will matter when you are trying to go for the multi classes, right? Multiple classes. That too, if you have any specific, let's imagine you have any specific use case where you want to identify any different object, right? With the highest accuracy. At that time, it will matter, right? So at that time, it's going to matter. But here, since it's a simple binary class classification, we are not going for the class imbalances of now. It will still take care, because I am trying to apply 3 level of convolution, right? With this many filters. That's the reason. All right. You can see here, this is the second convolution block. This is the third convolution block. And then we have our flatten layer here. And then followed by the dropout and the ANN, right? This is my input layer here, 128. This is my hidden layer, 64. And then followed by my last layer, which is the output layer, right? And in total, we are creating 14 lakh plus parameter, right? 14 lakh, exactly. Not 14 lakh, more than that. Yeah, 14 lakh parameters, right? So then guys, the last thing will be, I will try to compile my model, optimizer using Adam, binary cross entropy as my loss function, and matrix equal to accuracy, and just running this for 10 epochs, you can say. So I'm just running this for the train epoch. I am passing my train data set here, and validation data set equal validation data set, which we created using the generator, right? So Keras generator. So once I am able to fit this model, now you can see it is started running for the 10 models, and you can see the loss. Loss was initially very high. Okay, so the accuracy was very less, 63%. And as and when we try to proceed with the different iterations, in the end, you can see it is reached to the 75 and 80%. Now the accuracy is 97% and the 80%, right? So this is a huge gap, you can see, obviously. So when I'm trying to pass my accuracy here, I have plotted my accuracy. Now you can see here, right? So this is trying to give you the overfitting. This clearly giving you the overfitting because my train accuracy and test accuracy has a huge difference, right? Huge difference. So that's the reason. That's the reason. What we're gonna do is then you can obviously go ahead and add the dropout layer, and once you add the dropout layer, again rerun them so that there will be not such a big difference between the train accuracy and the test accuracy, because the train accuracy talks about the 97% and validation accuracy talks about only 80%, right? So this is then what I did is we went back, okay, and we added again the dropout layer here. Initially, this graph was without dropout, okay. So whatever graph you are seeing, it was without dropout. That is the reason I wanted to showcase you that that's the reason in first place I asked you not to add the dropout layer or any regulation, and then try to check how your model is behaving, right? So we can see here clearly it is trying to give you overfitting a 17% of the difference between train and validation accuracy. Then we went back, okay, we went back, added the dropout layer, and we rerun all the epochs. And now you can see here the gap has clearly been reduced, right? So you can see here there was a 17% gap. Now you can see the gap has been reduced, right? So it is around 95%, and this is going above the 80%, right? So gap is somewhat reduced, and you can see the loss gap is not that much, right? After the validation. You can see here the after we have taken both the graphs before the dropout and after the dropout for the loss as well as the for the accuracy. Now you can clearly say there is a huge difference between train and test, and after dropout layer regulation, the gap has been reduced, right? So that's the reason we wanted to experiment this one. And we can see here I have written some methods in order to reduce the overfitting, because we have seen clearly this overfitting, huge overfitting, 17%. So in order to take care of that, what we can do is we can add L1, L2 regularizer, we can add dropout layer, we can use batch normalization, and we can use the data augmentation as well, right? So data augmentation is what is very important in order to reduce this overfitting. Now what we're going to do is I have uploaded one random image of the cat from the Google, okay, cv2.read from this Google Drive. And let's see, this is how the image look like if we are able to detect this image correctly or not. Yeah, L1 or L2 for machine learning, but in the loss, you can always add that. You can add that L1 or L2 also. So there is a method where you can add this kind of a loss function. I've shown you loss function, right? So when you try to add this kind of a function, it is possible to reduce the overfitting, right? So I have uploaded this image, guys, and this image will try to predict, okay? So I am passing this image for model.predict, and let's see. So you can see here, it is trying to predict it as 0, means it is correctly predicting as cat, right? So 0 was cat and 1 was dog, right? So when I uploaded any random image and try to resize it before we pass it to the our model, and once our model did the prediction, you can see clearly it is given class as 0. So that means it's a cat, right? So 0 was cat and 1 was dog. All right, guys. So this looks very heavy since the number of parameters are more. But we were running only for the 10 epochs. That's the reason we were able to successfully run it on the Colab. If this would have been the huge epochs like 50,000 epochs, 1 lakh epoch, which will be running in the real time, right? In real time, you'll require more epochs in order to train your model from the scratch. That's the reason people are not going to train the model from the scratch. They are going for the pre-trained model, right? So whichever model I have shown you, right? So guys, this was quick. I think let's try to understand the Keras tuner also. I have given one example here for the Keras tuner. I'll make a quick walkthrough because we want to start more on the GPT side today. I will not go into detail, but I tried to showcase you how you can use Keras tuner to optimize your model parameters. Okay. So this is one good example. I will share this link also with you guys. So in order to do a Keras hyperparameter tuning, in order to use that for fine tuning your model, right? CNN model. So you have to install first Keras tuner. You can install Keras tuner. And then once you are able to successfully install this Keras tuner, so what we're going to do is we're going to import the TensorFlow and then Keras and NumPy. Okay, and we can check we are using the latest version of the TensorFlow 2.1.1, right? And then what data set we're going to take is we're going to take the multi-class classification here, fashion data set. Okay, the fashion data set talks about multiple fashion items like t-shirts, shirts, purses, right, shoes, and all this kind of a thing. That is the fashion data set. Amnis fashion data set look like, and we are passing this data set. Okay, we are this data set is available with the Keras. So we are trying to download using keras.dataset, fashion dataset, and I'm going to split that dataset into train and test. Okay, by using this fashion. Okay, and once I am able to split this dataset, guys, I will be using always the normalization technique. So train data set divided by 255 and test data set divided by 255. Now we can check the shape of the data set. It's a 28 by 28 size, right? Okay. So then once I am able to check the shape, guys, what I am going to do is I'm going to reshape. Okay. I'm going to reshape this data set in order to make sure that all the images are in the same shape when I'm trying to parse them, right? So in case if something is in different shape, so it should not hamper my model, right? So that's the reason I'm trying to reshape this model and trying to keep them in the shape of these images, right? Train and test images. 28 by 28 into 1. So since these are the black and white images, so that's the reason you can see here the channel is 1. Okay. So this is what we have taken the data set, we loaded the data set, we normalized the data set, and we're trying to reshape them also by using this one. Okay. So we are trying to keep this in the same shape of the data set whenever the we are trying to pass this data set, same shape as 28 by 28. That is the reason I'm trying to pass this data, right, and make it a consistent data set. Now, what we're going to do is we're going to build our model today. So we are creating one custom function here, guys. Okay. So what I'm trying to do is I'm going to create one build model function here. Within that build model, I'll be passing certain parameters here, like model equal to sequential. And within that model, guys, we are going to pass the 2 convolution layer. Okay. 2 convolution layer. Here I am not passing 3 convolution layer. First, keras add the convolution layer. I am trying to pass this conv filter here. Value will be 32, max value will be 148, and step will be 16. Okay. So just forget about it. This is just the filter size we are trying to pass it. So the kernel size I'll be passing here 3,5, and the activation function and the input shape. Okay. So this is what we are defining, just like we previously defined in our shape, right? So we have to provide the kernel size. We have to provide the filter size. How many kernels you are going to take? What is the size of the filter? And then what is the activation function? Input shape. Same way, we are assigning one more convolution layer out here. And then in the end, we'll have this flatten layer. And after the flatten layer, we'll try to pass it to the dense layer out here. Activation function will be ReLU. And mean max value, these are some hyperparameters which you can pass. What is the minimum value and maximum value for this one, okay? For these units, and how many steps. So this is some of the hyperparameters which are there. And in the end, guys, since we are trying to do multi-class classification, I will be using 10 neurons in the last layer, and I'm using softmax function. Okay. So this is what I have added, and I'm calling this as a model builder function. And once we build our model, I'm going to compile this model by using same method, model.compile. Here we are using Keras optimizer Adam. Oh, okay. And now what you can see here is now even for the optimizer Adam, they are trying to pass this some kind of a hyperparameter here. You can see here for the hyperparameter, what hyperparameter they are passing? Learning rate. And for the learning rate, they are passing these 2 values, right? So this t value, if you try to say it is 0.000 something will be there, right? E to the power minus 2, 1 into e to the power minus 2 or minus 2. These are two kind of a parameters they are passing for the learning rate, multiple learning rate. For loss function, we are using sparse categorical cross entropy, and then the matrix equal to accuracy. And then after this, it will be able to return us the model, right? So why we are trying to create this model in such a way that why we are not writing directly is because we want to use the Keras hyperparameter tuner, and within the Keras hyperparameter tuner only we'll be passing this entire model plus the different values of the parameters which will be generating here. Okay. So that's the reason first we created this model function as build model, and then we'll be passing this to the Keras tuner. So from Keras tuner, I am calling this random search function. And okay, and from random search also I am importing some hyperparameter function here. All right. So the tuner equal to now random search. Within the random search, we'll be passing our build model function. Then we'll passing our accuracy, and we're passing the max trial and directory equal to output directory, where the model different model will be saved, and then the name of the data set is fashion. Okay, project name. So once we pass this tuner, right? So the next thing will be tuner.search. So it will try to search the train image, test image, number of epochs, and validation split is 10%, right? 10% validation split we have taken. Now what is going to happen? Let's try to understand here. So since we are taking this search tuner as 3 epochs, so it will try to run 3 times, and it will try to take the multiple combination for the 3 times, right? Whatever the parameters we are passing here, like we have seen here, learning rate, I have given multiple. You can pass the multiple loss function as well. or you can pass the different parameter, whichever you want to do, right? So if you try to see here, guys, once we are trying to search this tuner.search and we are trying to pass it for the 3 epochs. So you can see here the trial summary, what it's going to do. It will try to take 3 epochs with different parameters, and you can get the summary as well, right? So once you are able to get the summary, you can check the summary as well for different trials, trial 1, trial 2, trial 3, how it is able to perform and what is your accuracy, train accuracy and validation accuracy, okay? And then in the end, when it will be able to finish, it will be able to give you the model equal to tuner.search guessed best model, right? Out of now, what is this get best model? If you have seen that when we try to run the grid search and random search, we're trying to take the best parameter, right? There is a function called as dot best underscore params. So it's the same way, since we are trying to run our model with a different combination, out of this combination, which one is the best model? This is what I am trying to get it from the tuner search, right? So tuner search dot get best model and number of models equal to one model I want, not all the best model out of that, and that will be the top model based on the accuracy rate. You can see here it is trying to give you the accuracy score 87% here, and similarly for all one, this one is 91%, okay, and the another one will be there. One is 91, one is 91, okay, and the above one, right? This one. So these are three times it will try to run the model, and then it will try to take the best model based on the accuracy. And this way you can do the hyperparameter. Very simple. I know it look complex as of now. Just you have to pass that. You just have to build first function model builder, and then you have to call this random search. And within the random search, you have to pass your training dataset, epoch validation dataset, and the different model, right? So whatever model you want to search, like this one, random search middle model. Objective is the validation accuracy and the trial and the directory for the output and project name, and then you can pass your data respectively. So it will try what is simply happening. Try to understand whatever epochs you are passing and whatever the parameters you will be passing here, right? So let's imagine here we are just simply passing 2 parameters for the learning rate, right? So you can pass different matrices. You can pass the different here the filter sizes, kernel number of kernel. This can be also a hyperparameter. So just for the simplicity, we have taken one as of now, but you can pass different parameters and you can pass them to the tuner search dot search, and then it will try to run with the multiple permutation and combination, whatever the epochs you are saying, and for every purpose. Now you can see here our main hyperparameter tuning parameter was the learning rate, right? So that's the reason. So we have seen the learning rate with different learning rate. These are the 3 epochs, right? So 3 epochs. With first it took the learning rate at 0.001, and second it is trying to take 0.01. So 0.01 and 001, these 2 different parameters it has taken, and for that purpose it has taken kernel 3 and second kernel as 5 for conversion 2, and then it has rerun for the 3 box. And then now it is trying to give you accuracy, right? Based on that, you can see here this is the accuracy, and based on that this is the accuracy 91%, right? And out of that, whatever the best accuracy will be there, it will be returned to you, right? In the best parameter, in the best model. And this is what the best model look like. So convolution 2D, convolution 1D, we are taking here 26 by 26 such 80 kernels, and this is 22 32 kernels, and then followed by the flattened layer, and then we are taking in dense layer 96 neurons. In the last layer we are taking 10 neurons as parameter, right? So this is how the model will be there, and then finally you can fit your model. All right, guys. So any questions, any doubt as of now? I know it look somewhat complex, but it is the simple trick is that you just have to pass the parameter. It will try to do the job. Multiple parameters with the multiple epochs. So here we are taken only one parameter, learning rate. You can see here in the bracket we have provided 2 values. Same way you can pass any values for anyone, right? So any parameter, let it be a number of kernel, let it be a neurons, dense layers, kernel sizes, filter sizes. Okay. Any questions, guys? Any doubts as of now? Before we move ahead into the generative AI parts. What do you think? Simple, complicated, or you need some revision for this one? Yeah, it's in Python programming language, sir. Yes, correct. So Murli Krishna sir is saying usually kernel is default in the program, so can we change the kernel size? Yeah, sir. That is what the Hyperparameter talks about. Compiler we are not using, sir. Anyone? It is by default compiler. Python 3 compiler it is using whatever Google Colab. I am not trying to change any compiler output, right? So what is the by default compiler there in the collab? That is same compiler we'll be using. Complicated I can understand, but if you try to go slowly through it, you will understand the main logic out here is we are trying to build the same way we have built the model. We are not changing anything. Only thing what we are trying to do is whatever the model parameters we are passing here, just we are taken one example that we are passing multiple values for the same thing, right? Yeah, I can understand repetition is required. Why not regulation you have not used for? Yeah, we have used, guys. That's the reason I have shown you, right? So in previous one, if you have seen that we have used the first dropout and then again we use the dropout. Without dropout, what was the thing, right? So that's what we are seeing here. If you are asking here why we have not used the dropout, so just for the showcase purpose, we don't want to make it complicated. That reason you can use dropout also here. So here in the layers also you can use dropout functionality also while building the model, right? That should not be the issue. You can use just to showcase you guys the purpose of this one is you can pass multiple values for the same parameters and it will try to run that with the different combination. Now you can see here, this is the combination number 1 for the learning rate and this is combination number 2 and this is running for the multiple epochs like three epochs each. And then it is once it is trial is complete, okay, you can see trial is complete and trial summary you will be able to get. And out of that you simply have to run one simple function which is called as guest based model. So it automatically it is giving you, it is not your headache, right? So decide like what combination I should take, what combination I should avoid, right? So simply you give a range of the parameters and try to dump it to the tuner. Tuner will try to run it for you and it will give you the best model. That's the reason we are using this tuner, right? So I will share this link, guys. Learning rate, yeah, learning rate is the one. If you remember our optimizer, right? This was our optimizer diagram. At that time, we have to reach to the 0 point, right? So if you remember our formula, or new weight, sorry, weight equal to old weight minus this eta sign we taken, right? And then we are taking this derivative dl by dw. So this eta is called as learning rate here, right? So learning rate means, let's imagine I started here at random point. So when I'm trying to start, right, based on this, whether I have to increase or decrease the weight depends on this derivative, right? At that time, when I'm trying to increase or decrease, how many units, like what speed I should go, whether should go by 2 times, 3 times, that is the learning rate decide, right? Whether I should jump from here to here or I should jump slowly. That is what the role of the learning rate. This eta is called as learning rate. That's what we are passing here, okay? One of the parameter for the optimizer. All right, guys. So I think we should proceed. Otherwise, we'll not be able to complete our chat GPT. Okay, let me stop sharing this one and let me start sharing the generative AI. Okay, and here especially the focus for today is we'll try to do a dry run. Okay, so I'm not going into the detail. We'll just give you the glimpse for this generative AI and then we'll try to go into the detail, right? Let me open that one. And then main focus today will be I want to showcase you the code where within the 10 line of a code you can create a kind of a model, right? Just like the ChatGPT kind of a model. Just let me run this one quickly and then we try to focus today. I intended to focus more on the ChatGPT applications, like how can we pass the prompt. That also I will try to showcase you quickly. Okay. All right. Let me share my screen with you guys. All right, so guys, let me know once you are able to see my screen and we can start then. So guys, in order to understand the chat GPT, what we need to understand is how the chat GPT coming into picture, right? And where this chat GPT fits. So everyone knows this diagram, right? And we'll try to take, this is one of the favorite diagram. Before we try to understand about the Gen AI, which is the talk of the town, everyone is nowadays talking about the Gen AI. So I want to understand that what is the Gen AI all about. Just give me 1 minute, guys. Let me adjust my screen so we can follow through. Okay? Just 1 minute and that's it. So my computer is usually slow today. That's the reason it's taking more time. Let me adjust the screen once again and then we'll go back. Okay, so let me share back my screen. Okay. So just give me quick confirmation here. You are able to see my screen quickly, so we can start. We are already getting some interruptions here. Okay, thank you. So let's get started, guys. Let's try to understand. Okay. So Gen AI, generative AI, right? So we already know that there is a difference between traditional AI and generative AI, right? We'll try to talk about what is the difference when we try to look at the examples, right? And before that, we'll try to understand when this Gen AI is fitting into the entire AI arena, right? This is what we need to understand. We already know that there is something called as artificial intelligence. Everything comes under artificial intelligence, right? We already know what is machine learning, what is the deep learning. So we have already seen the difference between the deep learning and the machine learning. Machine learning, when you try to consume the data, kind of the data it is taking, and based on the algorithms it is using, right? So in the deep learning, we are using the unstructured data mostly, right? And the algorithm we are using is CNN, ANN, and RNN, right? So this kind of algorithm. But when it comes to machine learning, we are using some statistical algorithms, supervised and unsupervised. And this is the statistical equation I'm using, and I am using mostly the structured data. Now, where the generative AI falls into picture, right? So what is the generative AI and how it is different from traditional AI? That's what we want to understand. Now, when we try to talk about the generative AI, guys, there are two parts. Always people try to understand that when we try to talk about the generative AI, people only understand one part, that is LLM, large language model, right? Large language model. But this is one side of it, right? This is the one side. So when we try to talk about the generative AI, which is the amalgamation of everything, right? It's a part of AI. It can use some machine learning concept. It can use mostly the deep learning concept as well, right? So when we're trying to talk about the generative AI, right? So it is trying to generate something. There are two parts to it. One is vision part, and the second part is the language part. Okay. So the chat GPT application which we talk about, right? It is about the language part. So what is this language part and what is the vision part? Let's try to understand now. So LLM is not an algorithm, guys. LLM is not algorithm. LLM is a approach or a concept, large language model, right? So large language model, it's what it talks about is large language model is especially concerned with the way we are trying to deal with the human language, right? Human language, the natural language and the human language responses. When we try to work with the human language responses, it is trying to deal with the concept called as large language model, right? So sorry, I'm writing again in the vision part. Okay, so LLMs falls into the language part. Okay, and there is something called as large vision models as well, right? LVM. So LLM and LVM, large vision models talks about the generation of the images, generation of the videos, okay, generation of the audio. So that is what is called as vision model. Now we can see that there is a Gemini model. Gemini Vision Pro is there and Gemini Pro is there, right? Gemini Max Pro. So there are two different models. One is dedicated to language, one is dedicated to vision. So the Chat GPT model, whatever we are able to see here, Chat GPT model talks about the language one. But if you try to look at the same model from DALI 2, okay, DALI 2 model, which is from the OpenAI only, right? OpenAI is the parent company and they have this product Chat GPT, right? OpenAI has this product which is called as DALI 2, right? So the DALI 2 is the vision model. Vision model. It is trying to generate image. It is trying to generate the audio, videos, right? Based on the input, whatever the input you are trying to talk about, right? So that is the two parts. First, we need to understand in the generative AI, right? So in generative AI, when we have a vision part and language part, so our main focus today will be on the language part itself, right? So how the language part works upon, we're not going to deal with the vision parts today. So in broad category, if I'm trying to talk about the large language model, right? So large language model are using the architecture which is called as GPT. Now GPT is the model, guys. GPT is the name of the model which they are using, right? And LLM is an approach method, large language model. This is not any model. And when we trying to talk about the vision, right? In vision model, they are mostly using this kind of architecture, generative adversarial network, GAN model. Okay. So GAN model, maybe they are using autoencoder model, variational autoencoder model. So this kind of architecture or other architecture of the GAN model they are using. So that's the reason it is called as vision model. So these are two different models. People fail to understand. People think that everything is a large language model. No, guys. Large language model is for the language purpose. For that, the model is GPT. Okay. So this GPT could be there, right? So it could be a transformer architecture, complex transformer architecture. Everything is a transformer architecture here. Try to understand. When I'm trying to talk about GPT, right? GPT, or I'm trying to talk about the BERT model here, right? So I'm trying to talk about T5 models. So these are some or variational autoencoder model, VAE model, autoencoder or encoder decoder model only, right? So this kind of a model, all of them are using transformer architecture. So transformer is the base, guys. So we are going to focus here on the transformers today, and I'm going to showcase you the application. how the transformer works, how the text generation is done using the transformer architecture. That's what I'm trying to showcase you today. I will try to talk about the prawns. Okay. So when I'm trying to talk about this kind of a different model which are available, like let me write the list. T5. T5 is the model which was developed by the Google guys, which was the model which was used for the machine level translation first. Then we have something called as BERT model, bidirectional encoder representation for transformer. Then we have a GPT model. Okay. So then we have something called as masked variational autoencoder or encoder decoder model. Encoder decoder model. So these are the different model available apart from the GPT, right? As a base architecture. But if you try to look at the thing, everything in the base, they are trying to talk about the transformers here. So, transformer is the base architecture. And what is transformer, guys? Transformer coming from the RNN only. So when we trying to see that, we yesterday seen this. Yeah. When you are trying to do more epochs, working with the virtual cloud based on the less time delay. Okay. So see epochs there, maybe what we can do is like if you want, if you don't want any time delays, maybe you try to shorten the batch sizes, right? So that could be one of the reasons. Otherwise, epoch is going to take the same time, whatever it will be, right? Based on the number of neurons and based on the whatever parameters you are suggested, right? Based on that, the epochs will take time to process. Otherwise, there is no such method. But I will try to follow up with this question. Nice question, sir. Bridge Kishore Agrawal, sir. Nice question. So how can we use less time delay when we try to run this one? I will come back to you, sir. But it takes usually times when we deal with a huge data set, it requires its own sweet time, right? In order to run that. Okay. So guys, transformer architecture, this is nothing but when you're trying to take the RNN, and we have seen why RNN fails sometimes, right? Complex architecture. Then that's why reason they use something called as LSTM. And then after LSTM, they created this kind of a model, right? Architecture, complex architecture. When we try to perform this complex architecture, it is called as transformer. This is what the agenda will be seeing today. How the transformer look like, how the text generation is done, right? So this I am going to skip as of now, right? So these are some example, right? How generative AI is different from the traditional AI. In traditional AI, guys, so if you're trying to do email filtering, right, whether it is a spam or not spam, or you're trying to do social media algorithm, sentiment analysis, normal sentiment analysis, right, or you're trying to do any kind of a fraud detection, object detection, voice recognition, or text to speech, speech to text, right, text to speech, speech to text, or if you're trying to do any language translation, normal language translation, right? So this is called as something called as now, or image recognition, face recognition, right? So, or could be a healthcare diagnostic you are trying to do, or let's imagine you are using some kind of a virtual bot, right? Virtual bot, which is very simple bot, which do not understand the high level human language, right? So this kind of example are narrow AI. Narrow AI, we already know that it is limited task, right? It is trying to do limited task. But in generative AI, what kind of a task we can understand, right? It is trying to generate something like content creation. So you pass any instruction called as prompt, right? And it will be able to generate a content on the basis of that, or the chatbot or virtual assistant which are trying to understand the human language just like the chat GPT, right? And it will be able to give you the answer back in the human language only, right? Advanced thing like image creation, right? Music creation, 3D model creations, right? Game development. You just try to give them the ideas and you try to create an entire virtual 3D images, right? Voice recognition, art recognition, this kind of a things, right? Or this kind of a deep fake, whatever we have seen, or image generation, or let it be a code generation as well, right? Code generation. So you are trying to pass one point, which I will try to showcase you with example, right? So all this kind of a capability falls in the generative AI, right? So let's move ahead. So we already know that how the generative AI is performing, right? If you're trying to pass this example, we already discussed multiple times. Still, I'll try to give you some this example just to make sure we are trying to understand what is generative AI, right? So if I try to give input as a music, right? 5 minutes of music, okay, here. And then what will be the base model which will be using in the discriminative AI? Kind of RNN, LSTM, GRE model, simple model, right? And then it will be able to give you bifurcation, right? Whether that music is rock, classical, or romantic. But when you try to pass the same 5 minutes of music, right, to a generative AI model, and this model could be a GAN model or autoencoder GPT kind of a model, right? So what is the output you can get? You will get a new music created, right? New music created out of the old music. So that is the difference. Here it is trying to bifurcate only. It is not trying to generate anything, right? But in generative AI, we're trying to generate actually based on the references, right? So if we get something called as class, probability, categories, that is not a generative AI. Generative AI means altogether we trying to generate images, videos, audios, or text or kind of a content. So that is called as generative AI, right? This is what we already know. So let's try to focus here. This part I will skip as of now, guys. And large language model, we already know. Large language model, why they are called as large language model? Because we are passing trillions of word, billions of parameters are there. So you already know what is parameter, what is hyperparameter, billions of hyperparameters and huge amount of data. Like you are trying to dump entire Wikipedia, whatever the data set is available in the internet, you are trying to dump that. That is why it is called as large. That's why it is called as large model. So large model, why makes them called, why it is called as large model? Because of the parameters. Since the parameter size in the billions, and the second thing is the data on which it is trained, right? The data is in the zettabytes. Zettabytes of the data, huge data they are trained on. So that's the reason they are called as large language model, and they are trying to replicate the human abilities to speak in the natural language. That's make them called as large language model, right? That's the reason they are calling them as a large language model. And we already know some of the implication: chatbots, right? Article writing, summarization, language detection, code writing, augmentation, image retrieval, all these kind of functionalities are there, right? So let's move ahead then. So this talks about different tools which are available, right? So just to make sure, this is the example, but just to make sure that we try to understand the generative AI in more detail, guys. So here I created one list. So our chat GPT falls into this category, right? Text to text, because you are writing passing one text, right? You are passing one prompt in terms of the text, and what result you are getting in terms, you are also getting a text in terms of the English language, right? So that's the reason it is called as text to text model. So apart from that, from the OpenAI ChatGPT, there are other models, like there are also Llama model is there, Gemini model is there, Gamma model has been introduced recently, right? Gamma 2, Gamma model, Llama 2 is there, Falcon is there, Mistral is there. There are many models, right? Which are trying to do the same job. Falcon, Mistral, right? Llama 2, Gemini model is there, right? So these all models falls, ChatGPT, all falls into text to text categories, right? Text to text categories. Apart from that, text to image, there is value 2, which has been given by the OpenAI. Then there is Imagine, there's a stable diffusion, mid journey is there, right? So this example I'll show you. And apart from that, if you're trying to generate something called as videos, right? Text to videos, the Sorka, this is the latest model which has been introduced by the OpenAI, right? So Sorka model, which is trying to generate up to 10 minutes of video, 10 minutes of animation video, right? Based on the text input. You just have to describe what you want in the animation video, and it will be able to generate up to 10 minutes of video, right? So that kind of a Sorka model that has been introduced by the OpenAI, right? So that text to video, there is a Synthesa, there is a Runway. Okay, the Runway is the most famous one, which you might have seen on the internet over the communities, right? The Indian communities. So then text to audio is there, right? One of the models. Sora, yeah, Sorka or Sora. Yeah, correct. Sheikh. Yeah, thanks for that. Sora model, right? Sorka, that model. So that was the recent one, which has been introduced this month only, right? So these are some of the categories, and this is very interesting, guys. So here we have one more thing. The Microsoft's OpenAI Copilot, right? OpenAI Copilot is there. And then we have a GitHub, okay? We have a GitHub Copilot, which is able to generate a code based on the text, right? So there are some other models also, text to music also. So these are the list, right? And the research wise and the text wise, image wise, this is the list. All right, guys. So let's move ahead then. So you can see here some live GIFs I have created for you guys. And this is what we're going to experience today, right? So if I try to write, this is a chat GPT. Okay, this is chat GPT. In chat GPT, if I'm trying to write one text, right? So generate the Python code for EDA using chat GPT. So this is how it will be able to generate, right? So if you try to see here, let me run this GIFs, okay? So you can see here. So you try to focus on the first image out here. What I'm trying to do is I'm trying to pass one data set here. So, and then I'm trying to write, can you please generate a Python code for the EDA? And you can see here, it has created entire code snippet for you, like pandas, load this one, then try to do null, remove the null values, then plot the box plot and everything, right? So this is what the example you try to see here. Then you can see here, this is a GitHub Copilot. If you try to see here, what it has happened, in the right hand side, you can see this entire code is there. Let's imagine this code has been built by someone else, right? So you don't know what is this code is doing and what is it, it is a difficult code, right? So what you can do is you can just simply pass one text, can you please explain me this code, and it will be able to, you can see here the user is trying to write what is, can you please explain me the code, and it has tried to start entire generation line by line explanation what this code is doing. Even you can go further and say, can you please simplify the code in the simple way, so it will be able to generate a new code out of it, right? So that's how the Copilot can work. And then this is the example for the Delhi 2, where you can see that we are trying to pass one prompt here, right? Monkey wearing a funny hat, and it will be able to generate a hat on the basis of the reference image. And this is the example guide Mid Journey, which is the bot which has been employed on the public channel, right? On the Discord channel, especially. And you can see continuously within a second, thousands of images are generated by this bot, right? So this bot is able to generate the image. People are writing the text on the basis of that. Within the fraction of second, it is generating continuously the images, right? So whatever the images as a response to the text, right? I guess this gives you a better idea that how the generative AI look like with the real-time examples, right? So let's try to understand now. Let's try to understand the base architecture. So we'll try to talk about the base architecture, and we'll try to understand why this has happened and how these things has evolved, right? Right from the beginning. All right, guys. So meanwhile, before we go into it, any questions, any doubts, guys, before we proceed? As of now, on the generative AI, ChatGPT, we're going to very quickly discuss this transformer architecture, and I will try to focus more on the implementation of the prompts, right? We'll try to talk about the chain of the thoughts, different prompting techniques, and I'll try to run few prompts out here for you in ChatGPT. Yeah, guys, any question, any doubt, please give me confirmation. We are good. You are able to follow, or is this too fast? Tell me your, yeah, guys, please ping me your thoughts, and then we can go ahead. Guys, once you are able to log in, you will get some free credit, right? So there will be some free credit. All good, thank you. We understand, okay. All right, guys, thanks for confirmation and thanks for your answers. So let's try to focus here. Okay, thank you, ma'am. Rish Kamli, Z Sunita Bhai, thank you. So guys, let's try to focus. The main part which I talked about is transformer, right? So let's try to understand the history, that how the transformer came into picture and why people thought that we should need to invent this kind of a things, right? So all this thing started back in 2013 and 2014, okay? So where the researchers from the Google, right? Researcher from the Google, they were trying to solve the problem of the machine level translation. They were trying to solve the machine level translation problem, okay. And what they taught is the team from the Google, and there was a Chinese guy, I don't remember his name. So the Chinese guy, he published the research paper. If you go back and try to search the translation, machine level translation, okay, the name of the research paper is machine level translation using neural links or neural networks, okay, using the neural network. So this kind of a research paper is there, okay. And this research paper talks about the limitations of the RNN, okay, limitation of the RNN and the LSTM when it comes to the machine level translation, where we require a huge context, right? Huge context. At that time, you'll remember that there is some limitation which are coming into focus, right? So when we trying to talk about RNN or LSTM, even though they are able to accommodate the different text data, sequential data, they have even created long short-term memory, but still, when coming to the huge data set, they were not able to maintain the context, okay? They were not able to maintain the context of the entire sentences, because in order to understand the context, okay, in order to understand the multiple sentence, or you want to translate from one language to another, you need to maintain that chain of the context, chain of the thoughts, right? And the something called as attention came into picture at that time, right? Attention is all need. So what they understood is that in order to maintain the context, in order to understand entire reality, interpret the words, you require some concept called as attention. And that's how the later on, after 2013 and 14, when this researcher published the paper about the machine level translation using the neural networks, the paper came into picture, transformer architecture paper in 2017, and which gave birth to today's nowadays what is called as ChatGPT and generative AI. Okay, so this thing started back in 2017, and the people called that research paper name was "Attention is All You Need." Okay, attention all you need talks about the transformer architecture. The transformer architecture which has the beautiful capabilities which are nowadays used in the generative AI, which can generate the entire content, right? Using this transformer architecture. Okay, this how shortly the history started, and why it started because of this recurrent neural network and LSTM neural network. They were not able to maintain the context. Let's take the simple example that before the transformer, how the prediction was done, how they were able to understand the things, right? So take this example. If I'm trying to write any sentence, right, and I want to predict the next word in the sentences, right? So let's imagine I'm writing this one. I took my money to the, okay, I'm to here. Now you want to check the next thing. Okay, what is the next word which could be fit here, right? So at that time, you will have some kind of a similar words which can become the next candidates for the word completion, right? So here, what we're trying to do is we are trying to decide some kind of a probability based on the context, right? Based on the context, since long short-term memory model, they were trying to maintain something called as memory cell, right? Memory cell. We have a memory cell. Within that memory cell, we're trying to add something, minus something whenever there is a change in the context. And based on I took money to the, obviously, what could be the probable reason? Out of my dictionary, I'm trying to rank them based on the probabilities. Okay, and I'm trying to take the next word, and when maybe I will start with the random, which could be most one, and then my model will be able to learn that which could be the best model, right? So I am trying to give here bank as a number one, possibility rank one, rank two, rank three, and based on the probability, of course, 0.6, 0.7, this will be 0.8 probability, right? And this is how they were trying to guess the next word, right? But this was simple when I'm trying to talk about the single word, right? So let's imagine this word now. The teacher taught the student with the book, right? Teacher taught the student with the book. Now, if you try to look at this, there is a syntactical ambiguity out here, right? So did the teacher teach with the book, or was the student was with the book, right? So now we have an ambiguity regarding the book. Who was possessing the book? Whether the student was having a book or whether the teacher was having a book, and who was teaching, right? Who was teaching with the book? Whether the teacher had a book and then it taught the student, or whether the student was having book and teacher was trying to teach it, right? So this kind of a words, when it trying to understand this kind of a word, these models fail, right? So this model failed to generate the next sentence, next word. That's why transformer was able to pay the attention. Now what people realize that you need to pay the attention, something called as attention mechanism is required in order to solve this ambiguity, right? So that's why they said that you need to pay the attention to the meaning of the words. And once you know the meaning of the words, then only you will be able to come up with the next sentences. Yeah, they are working on a word embedding. That's the next slide I will try to cover here. So when I'm trying to talk about the transformer, right? So now you guys understood why they required something called as attention. Now what exactly this attention means, okay? Let's try to understand in the simple words. So this is what the attention is all about. Attention means you are trying to create a relationship between the words, right? So what kind of a relationship we're trying to create here? If you try to understand, I am taken the same example. Teacher taught the student with the book, right? Now the same word will be written here on the right hand side and left hand side. Now, if you for the human being, it was very easy, right, to understand when we try to read this. Even though it was ambiguity, we were able to understand that the teacher was teaching the student with the book. Now, big book was with the teacher, right? So in order to make these machines understand, right, what they created is they created something called as attention. Attention are nothing but some kind of a weightages here. So they are trying to assign some weights, right? So this kind of a weightages, kind of a numbers. So numbers, kind of a weightages, right? 0.8, 0.0, point something. This kind of a weightages are assigned to the relationship of the words. Now, if you see here, if you see here the thin lines, right? The thin lines means they're not much weightages given to this, right? And when I'm trying to talk about these dark lines, right? Thicker lines. So thicker lines means if I'm trying to take the teacher and I'm trying to take the word book and I'm trying to draw a thicker line, means this indicates that there is a strong attention, strong connection between the book and the teacher. And how can I represent that in the mathematical manner in order to understand the machine so that it is trying to create attention around it, right? By creating the weightages. So this teacher and the book, this weightages, this number of weight, I'll try to give a high probability like this one, 0.91, right? And then when I'm trying to create the teacher and the association with the other words like student and the book, right? At that time, I'll try to give less weightages to it, right? 0.4 maybe. So this way, I'm trying to create a attention mechanism, right? So this way, the machine will be able to understand what is the relationship, what kind of a logical relationship I should plot between the words, right? So that when I'm trying to analyze the word, when I'm trying to understand the context, so my entire machine will be able to understand that this book was actually lying with the teacher, not with the student, right? So same way, we're trying to create this kind of attention. This is what who will give these weights? Machine will give the weights, not human. We just have to initially give the randomized one, and it will try to learn and it will try to create a mechanism automatically. So there are three metrics actually: key, value pair, and there is the attention mechanism, which is really used in this transformer architecture. Okay, so it will try to create that one. So this attention mechanism is a matrix which has been brought here. All right, so everyone now understand what is attention and why attention is required, and attention can solve this ambiguity and it can trying to create a stronger association between the words by giving more weightages, right? So this each word connected to the other word, if it has a strong association, that means it has a strong attention. Okay, strong attention. This way we can create our attentions. So let's try to understand. Before we try to understand this transformer, guys, very quickly I would like to showcase you this one. So what is called as sequence to sequence learning, because the everything start with the sequence to sequence learning only. So let's imagine sequence 1, sequence 2, sequence 3, and 4. Okay. So 1 to 1, 1 to many to 1, and many to many. In many to many, we have two categories. One is synchronous and one is asynchronous. Synchronous and asynchronous. Okay. Asynchronous. Just forget my spelling and try to focus here. Okay. Now, what could be the example, right? 1 to 1. So very simple example that I am trying to pass one image, right? We took the example CNN. I am trying to pass one image and it is trying to give me the probability that what this image belongs to, whether this is a horse, this is a zebra, or this is a dog, right? So one of them, my result will be 1, right? So I am passing one image, I am getting firm output of 1. So this is called as 1 to 1 sequence learning, right? 1 to 1. So now let's imagine next time 1 to many. What could be the example of 1 to many? Okay. So I am trying, example could be, guys, the image captioning, right? Image captioning. Let me rub this thing. So if you try to pass any image, right? And you want to create a caption around that image, what this image talks about, right? So at that time, I am just passing single input, right? My input is single, one image. But what I am trying to get, I am trying to get multiple words, right? Around it by using the caption it is trying to create for that image, right? So this kind of a learning called as 1 to many. Now many to 1. What is many to 1? Let's try to take the example. If we are trying to create some kind of a sentiment here, right? Positive, negative, or neutral. So this is what you want to understand, whether it, or you want to understand the emotions. You want to understand the emotion, right? Whether it you are trying to do a hatred speech, you want to detect whether this speech is hatred speech or not, right? At that time, what you are passing? You are passing 5 minutes of video, right? So this video or whatever the audio you are passing here, it will get chunked into the text, right? And that there will be multiple text you are passing here. On the basis of that, you need to find out the category, whether that was hatred or not hatred speech, right? So whether what was the emotion, angry, happy, right? Neutral. So this kind of a things is called as 1 to many. 1 to many. Okay. So this is called as 1 to many, and based on this kind of a learning, right? And now try to understand many to many. In many to many, very simple machine level translation, right? In machine level translation, what is happening? Machine level translation called as many to many, but asynchronous. Why it is called as asynchronous? Because the number of input you are passing, right? Number of input will not match to the number of output generated, right? Number of output generated. So there is no matching. Whatever, let's imagine you passed 10 words in English language, right? And you want to generate the German version of it, right? German, you want to convert in German. Whether the same 10 words will be converted into German, whether it will be a same 10 words or less or more, guys, right? So it could be less, 8 words, could be 12 words also possible, right? So we cannot have each and every word exactly copied into the different language. So there is a asynchronous sequence going on. So number of input will not match to the number of output, right? So that is called as many to many asynchronous. And when we try to talk about many to many synchronous, so very simple example, what we can see is a name entity recognition. Name entity recognition means whatever the sentence text I am passing, right? A sentence I have passed. Let's imagine in that sentence I have a 10 words. So within that 10 words, I'll be able to find out, is there any geographical location or any city we are talking about, right? Are we talking about any kind of a object, right? Are we talking about any human being? Are we talking about the currency, right? So are we talking about any place or any continent? So this kind of a things, entities, right? I'm trying to find out entities, name entity recognition. So this is called as, there will be exact one entity for every word, right? Whether that entity belongs to what category, whether it's a geographical location, time, date, currency, right? Human being or any other object for that reason, right? So that is called as many to many, but this is synchronous. Whatever input you are passing, it will try to match the output, same length, right? So that is called as synchronous. All right, guys. So let's try to understand. And embedding, we already know, right? So embedding, I'll come back here. So this is what the transformer architecture look like, right? So we'll try to focus on the transformer architecture. Now, when I'm trying to understand the transformer architecture, the main thing out here, the main part is encoder and decoder. Okay, these are the two main parts. The decoder job is to decode the message, decode, translate one. Okay, and this encoder job is to encode them, create a hidden state, hidden encoding, right? Hidden encoding. This is the job, and this is sort max function out here, right? Sort max function probably used for the multi-class classification. This is the job of the sort max function. Okay, so there is encoder, decoder. There is a sort max function. Now you can see there is something called as tokenizer here. Tokenizer. What do you mean by tokenizer? So tokenizer is a numerical representation of the words. Now tokenizer in simple words you want to understand. Let's imagine this is the sentence, right? We are passing here. So if I try to break these sentences into the different words, so we are trying to do a tokenization. Once we do the tokenization, I am converting them into the number format. Correct? So number format that is called as number, because we already know that our machines only understand the numbers, not the text. And now we are dealing with the human language. So everything will be in text, right? So we convert that text into the numbers. How we convert? We break the entire sentence and paragraph into the sentences into the words. And we take one word, and for every word, we try to create a numerical representation, kind of a number. Let's imagine 10. 10 represent this one. Okay. So that is called as tokenization. Once we do the tokenization, numerical representation, we are trying to create something called as embedding now. So now try to understand why embedding coming into the picture. Okay. What is the role of the embedding? Very simple thing. When I'm trying to do vectorization, right? So when I'm trying to do numerical representation, let's take the word look, like, sorry. Okay. Like. So now this like word, if I want to convert them into the vector representation, right? It is called as vector representation. When I'm trying to create a numerical representation, vector will be one dimensional array, correct? One dimensional array is called as vector. So now how it is converted, try to understand. Yeah, guys, we'll try to share the PPT as well. All right. So this like word, let's imagine first I want to create a dictionary size, right? How many words, maximum words within that I want to represent this thing. Let's imagine I took 10,000 here, okay? Out of 10,000 metrics, okay? So metrics will, this one dimensional array, which is called as vector now. So vector will start with 0, will end up with the 10,000 positions, right? 10,000. And within that, if I want to represent like, so let's imagine like is lying at a 1,000 position. So at 1,000 position, it will show 1, and rest 9,999 zeros will be there. Okay. So this is what is called as vectorization of the words. Now try to understand what is the difficulty here. If I try to represent them, first difficulty will be the dimensions. I need to deal with the high dimensions. So obviously the computations will be very high. Okay. And then second thing which I need to do is semantic search. Semantics, right? Semantic search. So what do you mean by semantic search here? Any guesses, guys? What do you mean by semantic search? What the semantic search talks about here in the natural language? Why it is important? Because now everything is based on the semantic search only. Let it be a vector database. Nowadays, which the chatbots are using, they are using embeddings and the vector search. This is a hot topic out here in the market. When I am trying to deal with the industry projects, everyone talking about the semantic search, everyone talking about the vectorization, vector databases, right? Everywhere. So any guesses, guys? Any guesses? What is this vector database or semantic search is all about? Vector data is forget as of now. Vector we already talked. We already spoke about the vectors. So what is semantic search? Anyone would like to tell me? What do you mean by semantic search? Quickly, guys, we need to cover the prawns as well. Okay. Anyone would like to enlighten us? Yeah, what is meant by semantic search? Okay, let it be. So guys, I will be the winner. I will tell you what is semantic search. Let's imagine there are two words, right? Like and the love. So these two words, when I'm trying to take into consideration, right, in terms of the sentiment analysis, right, in terms of the sentiment analysis. Okay, now let's see who's the winner out here. Understanding the words from the search intents and their context. Correct. Searching with meaning. Correct, guys. Semantic search is a keyword. No, guys, it is not a keyword search. Semantic search, keyword search is different. It is like search engine. Lexical search, we can call that as a lexical search. We are trying to match the words to words. Semantic search means what it try to understand is context, means love and like are most probably the same words, right? The meaning of the one word. Correct. We are trying to understand, Kalpana ma'am, correct? So ma'am, what we try to understand is Lexical search or the keyword search means understanding the meaning of. Correct, guys. Correct. I just remember. Correct. So guys, the like and the love, these words are similar, right? Even though the each and every word is not matching with them, right? So if I'm trying to do a word matching, right? Yeah, correct, guys. Sonali ma'am, correct. Yeah. So if I want to understand from the sentiment view, both are positive words. So for that reason, I need to compare and I need to understand both are similar word, right? So that similarity search based on the understanding meaning is called as semantic search, right? For that purpose, if I want to do, yeah, correct, correct. You are and you are, correct, correct. This kind of words, correct, ma'am. Awesome. Correct, correct. Awesome, awesome, correct. So this kind of words, right? And then try to understand what will be the problem here. So when I'm trying to represent this kind of words with this kind of a big vectors, right? So which are like this one. So at 1000 position, I'm trying to take one, everywhere it is 0. And let's imagine this is a like word, okay? And this is love word, right? At a love word, let's imagine it is stored at 2000 position, okay? And at 2000 position will be 1 now. Now, when you try to compare this matrix, right? You try to subtract the matrix, the resultant matrix will look like something like that. There will be 2 differences. So this way, if you try to match, it will be very difficult. That's the reason, okay, the embedding came into picture. Now, embedding, what is the job of the embedding? They're trying to reduce the dimensions. They try to reduce the dimension of the words and try to keep them in the numerical representation only. How? Very quickly, we'll try to understand this one, okay, because we need to understand the transformer architecture as well. This one. So that's the reason, guys. That's the reason it will try to understand how it is going to reduce the dimension this way. Now, what I'm going to do, I'm going to write on the row side all the words, right? All the words. And here I will try to take the features. So it is called as feature embedding. Feature. What could be the feature I can take? Living being. Okay, living being, feline. I'm writing feline. Okay, feline means it is belonging to the cat category. Okay, that kind of animal. So human, living being, human, right? Gender. I'm trying to take this kind of a thing, gender, okay? Then royalty, right? Royal. This kind of a feature I'm taking here, okay? So can cat belong to a human being? No, not possible. So I will give a negative weightage. Sorry, not living being. Living being, it can be, yes. So I will try to give a positive weightage. But can human belongs to a human being? No. So I'll try to give a negative weightage. Can it belong to feline? Yes, it can belong to feline. Can it belong to royal? Yes, the cats could be royal, right? Royal people can also have a cat. So I'll try to give a kind of a weightages. So this kind of a numerical representation, you can see here, for the cat, we have created this kind of a numerical representation. Now, instead of having 10,000 dimension, I'm trying to reduce them into 50 or 40 dimension and trying to create a new dimension, okay? Who are giving this feature? We are only deciding this. We are only deciding this feature, okay? And then when I'm trying to convert them into this kind of embedding, okay? So now when I'm trying to plot them, if you see here, when I'm trying to plot them, the man and woman most likely same, right? And king and queen. So you see the distance between them. They are placed at the closest distance. This way, based on the distance, we can create a similarity. Based on the distance, based on the cosine similarity, right? Euclidean. This is called as Euclidean similarity. Euclidean distance and cosine similarity, we can find out the similar words. That's the entire reason we are trying to use the embedding out here, right? Okay, I think we understand this one. Let's move here, okay? So we have talked about positional encoding. We talked about encoding. Positional encoding, I will explain again. Softmax function. These are the component of the architecture. Now let's try to understand how it is tried to generate the machine level translation, okay? So let's imagine I am writing one word, ish. I am Vikas, okay? I am Vikas. This is what I am trying to write. And let's imagine I want to convert it into the Deutsch, German, okay? German word. So it will be called as Ich bin Vikas, right? Simple example. I know most of you have heard this example. Ich bin Vikas. This is how it will look like, right? Maybe next time I'll take the second example. So guys, Amar has shared the attendance link. We can follow the links, okay? So guys, what is going to happen? Let's try to understand out here, okay? So I am trying to take this I am Vikas word. Now what will first happen? Tokenization. The first step will be tokenization. So tokenization means I'm trying to create a numerical representation here. I am Vikas. So I will be represented by 145. M will be represented by 233. Vikas will be represented by 607. Now you know, guys, right? What is the difference? Here, once we convert them into the, because of the high dimensionality, the semantic search will be difficult, right? So that's the thing, the step two. Step two, I'm trying to create the embeddings. So now embedding will try to reduce the dimension and it will try to plot the words in this way. So that's the step two. We'll try to create an embedding feature representation. feature embedding, right? So once I create the embedding now, so what is going to happen at the step 3 is, let's try to understand here. Step 3 is positional encoding. Now, what is positional encoding? Let's try to understand here. If we wrote the same sentence that the teacher taught student with the book, right? Teacher taught the student with book. So this is what the sentence is all about, right? Okay. Yeah, attendance is shared by Amar, guys. Okay, you can follow that in chat box. She recently shared and he'll keep on sharing. Okay, guys, let's try to understand now why the positional is important, right? So if you try to swap the position, okay, so instead of the teacher's position, which is at the 0th position, right? This is 1 position, this is 2, this is 3 and 4. So if you don't retain this position, if I try to swap the words, I try to put it here, what will happen? Entire context, right? Entire context of the sentence gonna change, right? So that's the reason positions are important, right? These positions are important. That is why we are trying to create the positional encoding at step 3. Okay, step number 3. This is step 2, embedding, and this is step 1, tokenization, numerical representation. Correct. So once we create this position encoding, so that we try to keep the context intact, so the context will not be changed. Then this is called as encoder now. Now, if you try to see the encoders, encoder is divided into 2 parts. One will have a feed forward network. You can see here the same artificial neural network which you have seen, ANN, is present out here. Okay, which will help us to understand the read the weights and biases and try to understand this entire numerical encoding, everything. Okay, and there will be something called as multi-head attention. What is multi-head attention? Because the teacher can have a relationship. Okay, teacher can have a relationship attention with the book. Okay, so this is single attention, but teacher can also have a relationship with the student. Teacher can also have a relationship with the class, right? So this is called as multi-head attention. So we are trying to create a multiple attentions here. So that is called as multiple attentions, right? Yeah, guys, the attendance link will be shared by Amar, okay, shortly. So he has shared once, he will keep on sharing after 5 minutes. Okay, so this is called as multi-head attention, which will help us to understand the context and try to convert them into the numbers, right? So try to create the entire context and try to understand the things, and then there will be this two kind of a things. Now here in the artificial neural network, along with it, there will be architectures, right? Like kind of architecture. BERT model will be there, or GPT model will be there, right? BERT, GPT, T5, this kind of architectures will be, or masked encoder, okay, mass encoder. This kind of architecture are present along with this attention and the feed forward network, right? So this will try to create one output here. So whatever the information positional encoding after everything, it will go through the attention. It will try to create attention between different words and sentences. It will try to create the words. It will try to learn the weights and biases. And whatever the output generated now, it will pass on to this decoder here. Okay. So this decoder, now what is happening here? In decoder also, we have a similar architecture. You can see here, there's a feed forward network. There's a multi-head attention here. But now this decoder, they're trying to receive the two things as an input. Okay, two inputs are received. One input is which is coming from the encoder. Okay, Amar has shared the attendance link, guys. You can please mark your attendance. Okay, refer to the chat box. The chat section, he has sent the attendance on, right? So guys, now two inputs are coming. One is original input. So whatever this original input we had after this position encoding, we are passing this one. Okay. Okay, this is what we are passing. And then guys, we have something called as now whatever the output generated here, right? So let me show it to the different color. So whatever output is generated by the encoder, same that will go inside the decoder also. Now, what is going to happen? So encoder has the original information plus encoder has the decoded information. And this way, decoder will try to understand what is this numerical representation talks about, what kind of a sentences, right? And this way, it will try to learn. And then after that, it will be able to create the translation out here. So now the translation, how it will happen after the sort max, it will try to create again the token, right? Tokenization. And these are the numerical representation. Then this numerical representation will get converted into the sentences. And this how the machine translation or language translation will happen. All right. So this is how the entire dry run we are seeing, how it is able to generate the machine level translation. And this is the architecture through which it is able to convert, it is try to correct the attention, it is try to learn. And this is why it is very, very powerful architecture. This is why there everywhere the transformer architecture is a base for this generative AI. All right. So guys, I hope you are able to enjoy this session. Let's go into the prompt now, and I will try to showcase you some prompt example. Now we have a limited time. So I will not run anything, but I have already run some prompts. So I will try to showcase you those prompts and this prompt result as well, right? So let's try to understand what is prompt now. Prompt is very, very heart of the entire chat GPT application, right? Prompt means nothing but a query, right? A kind of a text which you are trying to pass to the GPT models, right? Or this kind of a chatbot models. So when you try to write anything, any query, any text, that text or query is called as prompt, right? So prompt, and then whatever these prompts are there, yeah, feedback link will be shared by Amar, guys. So he's sharing that link. He has shared 2 times. We'll share it again once again. Okay. After every 5-10 minutes, we'll share it. So guys, what is prompt engineering then? Prompt engineering means, so the only way to get the correct output, right? Only way to get the correct output, all right, from our model is the way we are trying to pass the prompt, correct? Way we are trying to pass the prompt, the way very accurately you are trying to pass the prompt, the generation of the output will depend on the prompt. So the art of creating such prompt is called as prompt engineering. Okay, the constructing such a prompt so that our model will be able to understand, will be able to generate this thing, which is called as prompt engineering, right? So this prompt engineering, it is called as prompt engineering, and prompt plays a very, very important role. The way you are trying to write the prompts, or what is something called as prompt tuning, right? Soft tuning. Something called as prompt tuning or soft tuning is there, right? In soft tuning, what we're trying to do, whatever model we have created, right? For that model, we try to pass some kind of examples. So what is the prompt? Okay. What is the example prompt? And if we get this kind of a prompt, what should be the probable output, right? What should be the probable output? So this kind of a training, probable output. So this kind of a training, this kind of example we are trying to pass, and then we are trying to fine tune our models, right? We are trying to do a fine tuning of our models. So this is very, very important thing, because if you try to generate the or try to train the model from the scratch, it is impossible because it contains billions of parameters, right? Billions of parameters. So that is why it is called as fine tuning, soft fine tuning, okay? Prompt fine tuning model. So for that reason, we have a different methods. So this is called as zero shot, one shot, and few shot learning. So let's take the example, what is few shot, zero shot, one shot learning, and we'll try to talk about the chain of the thoughts as well, right? So zero shot means I'm not giving any example, zero example. So whatever knowledge it has previously, right? Based on the knowledge, it will try to answer your question. Yeah, with them, yes, Amar will share that attendance. Okay, once again. So based on this zero knowledge, guys, it is trying to create the answers, right? So at very equitable answer. Yeah, guys, you'll get to know these things. Okay, Amar will talk about it shortly. So let's imagine if you give one sentence, I love the movie, and you ask your chat GPT model to classify it, right? But you are not saying that any example or anything. It should be able to give you the prompt, right? So that it should be able to give you that this is a positive sentence. This is called as zero shot learning. Now you are not telling explicitly your model, right, what to do. So same way, if you are trying to write one example, okay, classify this review, I love the movie. This is positive sentence. Now you are asking the next sentence and try asking it to classify. Or here you have taken two examples, what is the sentence and what is the sentiment around it, then you are asking it to create. So this is called as few shot, means you are giving more than one example. Here you are giving only one example, here you are not giving any example, but it is trying to generalize based on the knowledge, right? And there is something called as context window here. Context window, yeah, guys, you can get this number easily. You can connect on the LinkedIn as well. Okay, so all the information you will get. Fateh Kunwar, okay, so you can connect me on LinkedIn, you will get all the information. So guys, context window means number of tokens which LLM can provide an inference on it. That is called as context window. How many context window we are trying to pass here, okay? So there is a limit. So I guess we have covered everything. We already know how the chat GPT get trained. This is the 3-time process, okay? So the SFT model, the reward model, and this we already talked about. So let me share the prompt part here, and then we'll try to discuss one simple thing. Okay? Yeah, guys, I'll share all the PPTs, okay? Don't worry. Murtuza, yes, sir, ma'am. Yes, I'll share this one. So guys, attendance link is shared once again. So just give me 1 minute and I'll try to showcase you, okay, how the prompts will look like. And one simple prompts where I'll try to showcase you, and one my example, 10 line of code I'll try to showcase you. How can you create a chat GPT kind of application? Just a minute, I'm trying to share this one. All right. So let me share my screen with you guys. Okay, so I think you are able to see my screen. So one thing we already spoke about the prawns. Okay, so what I want to talk about is the chain of the thoughts. Okay, chain of the thoughts. This is very important. What is chain of the thoughts? So very simple example. Let's imagine you are trying to give this kind of a problem to ChatGPT, right? So initially the guy Roger, okay, or I am writing. Roger has five tennis ball. Five tennis ball. Okay, this is what you are talking about. Yeah, okay, guys. I'll write my full name so we can. Okay. Okay. So guys, let's try to understand what is called a chain of thoughts, which is very important. Chain of thoughts prompting. Okay. So chain of thoughts means what? Let's imagine you are trying to solve any problem or you are trying to generate any code, right? Okay. Thank you for that. Yeah. So let's try to understand, guys, how this is able to generate the code, right? So whatever the text you are writing, based on that, how it is able to generate the code is based on the chain of the thoughts prompting. What is chain of the thoughts prompting? Let's try to take the example. If we have a person which is having five ball, right, and he buys two more balls. He buys two more balls of the two cans of the ball. Okay, two cans, and each can contains, right? Each can contains the three balls. Now, how many balls it will have total? So how we going to calculate this one? Answer is 11, that we know, right? So, but how it is going to connect or connect this chain of the thoughts? Chain of the thoughts means you're trying to bifurcate the problem into simple steps like this one, and then you're trying to tell like now in order to solve this problem, what we have to do? We have to understand initially how many balls were there, two balls. Then he bought the three cans of the balls. So each can has how many balls? Let's imagine two balls. So how many balls will be there? Three into two, six. So in total, how many balls will be there? Eight. This way, or we can say there will be three balls in each can, right? He bought the three balls. So it will be nine. So the answer will be 11 this way. Okay. So this way. So this kind of a steps which I'm trying to write here is called a chain of the thoughts. So in order to understand or in order to give the example to the our entire chat GPT model, we need to understand or create this kind of a chain of the thoughts, right? So like this one, the Roger has five tennis ball, he bought the two more, and each tennis ball has the three balls, and how many tennis balls you feel, right? So here we're trying to write like what is the step one, step two, step three, step four, and how the model should give the output. So that is called a chain of the thoughts, and this is the way how it is able to generate the output, right? So let's take the example, guys, of the prawns. Okay, I have written here the prawns, and you should be able to understand the use case, right? How it is able to generate the output out of it, right? So let me stop sharing this one and let me share the different screen now. Just a moment. All right, guys. So let me know if you're able to see my screen correctly. Okay. So let's imagine how we can pass the prompt and it will be able to generate the entire output around it, right? So let's imagine, guys, what I have done is, okay. So let's imagine we have dumped one data set here, okay. So what is the data set name? Iris data set. And what I'm trying to write here, what are the key features and the target variable, okay. So now look at the thing, how we are writing the prompts, okay. I'm just writing, I'm not giving any data set. This data set is inbuilt with the chat GPT, right? So out of that, it will be able to generate this kind of a feature, right? So I'm asking what are the key features and what are the target variable. You can see here, it has generated the key features. It is trying to write about it, sepal length, sepal width, petal width, and what is the target variable? Species, right? So this way. Then what I'm asking is compute and describe the mean and the standard deviation of this column, right? So all of sudden, guys, once we are trying to write and based on the features in the data set, I'm trying to write here, feature on the data set. So you can see here, it has generated the entire code snippet, right? So how we can print the data set, it is trying to take the head, then it is trying to check the mean, standard deviation, then it is trying to print everything, and you can get the print and everything, right? So same way, what I'm trying to ask is create a histogram illustrating the distribution of the sepal width and what insights can be drawn from the visualization. I'm directly writing the chain of the thoughts here. Try to understand. This is called a chain of the thoughts. I'm asking to plot a histogram. Then I'm asking it to analyze this sepal width and tell me what can be the insights drawn from it, right? So it is try to generate entire code here, how to write a histogram. And once it is try to write the histogram, guys, you can see here it has generated. By examining the histogram, you can gain the insight into the variability and the general pattern and the sepal width in the data set, number of beans and visualization going to deal with this one, correct? So then I'm asking, please, can you explore the correlationship? Now, explore the correlationship, okay, between the sepal length and the petal length. So it is trying to create an entire code for me. It is trying to create a correlationship matrix, and it is trying to plot the correlationship and everything, okay, out here. So you can see the correlationship is plot between correlation C is close to 1, -1, and the correlation between this is close to 0. And this is what you write. Then what I'm trying to write in the end, guys, so describe the steps involved in training the random forest algorithm on this data set for predicting the species, right? And what accuracy is achieved. What was the accuracy achieved? So this simple prompt I'm passing, and you can see here beautifully it has created the entire model for me. All right. So you can see here it has imported the matrices, it has imported the random forest classifier, matrix, accuracy report, classification report, 10 test split. Okay. Then it is trying to drop the last column taking as X, this is as Y, trend test split, everything it is taken. Then it is called the random forest model, random state it has taken, it has fitted the model, then it has predicted, and it is trying to fit the entire accuracy and classification report for me. And it is trying to give me the next steps as well here. What could be the next step? Potential further analysis and improvement of this model. And it's trying to give me the hyperparameter tuning here. It is going to do a hyperparameter tuning for the next steps. So it is trying to tune parameter grid it has taken, and it is passing to the grid search CV. Correct? And then it is trying to create a cross validation, and then it is trying to improve. This could be the some methods where you can improve, or you can also check the class imbalance. All right. So I guess, guys, this was the awesome explanation that how you can use the chat GPT for any purpose which you want to use, right? So here I am trying to showcase one example. Because of the time limitation, I'm not able to see you or showcase you some other example, but you can see here I have passed one entire data set here. If you see here in the beginning, and it is able to give me directly all the analysis here. This is the financial report data which I have passed with tool. So I uploaded this data, okay, this data, and I asked it, can you please create an entire report analysis for me? The daily rate analysis report, default rate analysis. It is trying to create an entire thesis, entire report for me, along with the actual numbers as well, right? Along with the actual numbers. So these are some example how the chat GPT and the generative AI is powerful and is able to create a model, right? So guys, the last example, okay, last example, very 10 line of a code within 5 minutes, I would like to finish. What is the difference between ChatGPT 3.5 and 4 version? Guys, it is number of parameters and the accuracy. That is the difference. Okay, attendance will be shared by Madman, sir. Okay, let's try to understand. I've created one simple app here. Okay, so what this app is talks about the article writer. So you can pass any keyword here and you try to write this button. Okay, it will be able to generate a blog around it. Let's imagine I'm trying to click here. What is life? So it will be able to generate. Yeah, free version it is possible. I'm using free version only, sir. Key, free key only. So here. So it has written. So now you write. What is generative? Okay. So let me correct the spelling. And let's see how it is able to generate anything. A writing blog, right? So see here it is the moment I hit the button, so it has written everything. See here, generative adversarial network, generative AI has been useful application, and it has creating entire blog, right? So this is the beauty of the generative AI, guys. You are seeing, and how to create this app? Very simple. 10 line of a code. Let me explain you how to create this. You require only 2 files. First file, this the libraries, the requirements. Okay, what are my requirements? OpenAI. I think I should increase the font. This is better. So only 3 libraries I will require. Okay. So first one will be OpenAI version, then Streamlit. Streamlit is to create this UI. Okay. So that's the reason I require Streamlit, and then Streamlit one more version, JavaScript. Okay. So these are the 3 libraries which I'm saving in requirement.txt, and then I'm writing my main file. Okay. So this is my main file, article writing.ui. Here, guys. Yeah, you can make this model through ChatGPT, guys. I'm using ChatGPT only. You can see here in the code. Only 10 line of a code I have written here. So try to understand how to create this app. From OpenAI, I am importing OpenAI, and from Streamlit, I am using Streamlit as ST. This is what I have done. Only 2 imports I have done here. After that, I am creating something called as client here. What is this client? I am trying to, okay, I am trying to generate something called as client here. Client is nothing but I am trying to connect to the OpenAI. And here you will require your OpenAI key, okay? This is the key which you require. So you can generate this key by going to the OpenAI. You can directly generate this key, platform.openai.com, okay? You can go to the ChatGPT platform and you can generate this key here. So in the platform.chatgpt, you will have option to OpenAI key, and you can click on this create new secret key. You can write the name and you can generate it. Since I already generated, I'm not trying to give generate again. Okay, that's what you have to generate. And once you generate, you can paste the key here. Okay, once the key is pasted, guys, now you have to write the main function. Very simple, 10 line of a code. What you have to write first? You need to generate a UI, right? st.title. So what is this st.title? This is what I'm talking about. Okay, st.title. So I'm writing st.title, article writer. Then I'm writing notes, st.text. Okay, so this is the text box we are talking about. This text I am writing heading, enter the topic here. Okay, so once I write enter the topic, whatever the topic will write, it will get stored in the notes. Then I want to write a prompt. See, this content means this is the prompt I'm writing here, internal prompt. So what prompt I'm writing? I want to write an article, short literature review on the topic and whatever the topic is, plus notes. Notes means whatever the topic you will enter in the text box. Okay, sorry, here in the text box, that topic, it will try to club it here along with this internal prompt. And then there is a button, st.button generate article, right? So this is the button we are talking about. The moment I hit this button, what will happen? It will try to showcase you the spinner, and then response equal to this client, whatever the chat GPT model we have taken here, that chat completion. This is the function chat completion create. Okay, and you can choose your model, whatever you want. Chat GPT 3.5 turbo I have chosen, and you have to write role as a user and content equal to whatever the content prompt I'm passing here. So once you pass this prompt, it will be able to generate, and whatever the generation is done, that is the description which I have stored here, and that I will try to write here, st.write. That's it, guys. This is the simplest way MATLAB code convert into ML. Yeah, you can check online, sir, possible. Okay, this way. And once you have this, guys, written, so you can simply go and try to run the thing locally also, or you can go to the Streamlit cloud. In the Streamlit cloud, if you go to the Streamlit cloud, this is the link which I will share with you guys. So here, if you try to come here, you have to log in. So we have this file ready with us in the GitHub. Simple, come here. Once you come to the home page, guys, you will have an option new app. Okay, this is the new app. I'm sharing this link. So with the tutorial, you don't worry, you can follow this link. So click on the new app, guys. Once you come log in here and click on the new app, so you have an option to here. You have to choose the repository name. So this is the repository name which I am having. So you can choose the repository name here. Once you choose the repository name, you have to choose the branch main, and you have to write the main file name. So for us, what is the main file name? Main file name is article.py. So this is what you have to write here, article.py, and that's it. This will come automatically name, and you have to click on deploy button. Once you deploy, guys, your app is ready here. Okay, this is how it will try to showcase you that it is app is getting baked, and once you bake the app, your app will be ready like this way. Okay, the final process will be done, and this is how the app will be ready. All right. So hope you guys are able to enjoy this session. So we'll try to close our session here, guys. Now we have any questions, anything, we can take it here for 5 minutes, or anything you would like to discuss, any comments, any feedbacks, you can share here. Okay, I will share these links, guys. Don't worry. Yeah, feedback link, Amar, please share the feedback link once again with everyone. Okay. That you will understand, ma'am, which prompt to give. Based on the use case, you will have to write that. Okay. All right, guys. So I think Amar, they can unmute themselves, right? If they want to speak, anyone. Yeah. Okay, Reshma Nagavdi, ma'am, thank you. Yeah, guys, you will get this LMS. You will get this LMS. Thank you, guys. Amar, I think can you give them access? If anyone want to speak, they can speak. Rajeshwari, thank you, ma'am. Banushri, ma'am, thank you. Thank you very much, guys. Okay, thank you guys. Let me see if I can allow you participant. Yeah, guys, I have given you access. So if someone wants to talk, they can unmute themselves. Thank you, Bhattacharya sir, Bhanushri ma'am, thank you. Feedback will be shared once again. If someone want to unmute, they can unmute and speak, guys. I've given you access to unmute. Anyone wants to speak anything? Go ahead, please. Yeah, guys, go ahead. Please, or want to speak.
Thank you. Thanks a lot, sir. It was a very great explanation of transformer from your side.
Okay, thank you, ma'am. Anyone else want to go? Yeah, thank you.
Thank you, sir. Very good explanation and experience you have shared. Thank you so much, sir.
Thank you, Naidu, sir.
Thank you very much, sir. It's really a fruitful session, and we have learned a lot of things. And practical oriented, you have shown it. Very good session, sir. Thanks a lot, sir.
Yeah, thank you, ma'am.
Thank you, sir. I could learn what is artificial intelligence practical with all programs and algorithms like deep learning, convolution, neural network. Thank you.
Yeah. Good evening, sir. Thank you. It was an excellent session. Whatever teach you, I think it was full of practical knowledge, and it was awesome session, sir. Thank you.
Yeah, thank you, Fateh. Thank you.
Excuse me, sir.
Yeah.
Sir, I want to ask you one question. If we want to use the images kind of data or textual data for our research, so can we use some images or set that you had shown us at the time of these sessions? Is
Yeah, you
it
can.
legal to use, or
Yeah, you can
if
use
it
it.
is related to us, if it is related to our research?
Yeah, you can use, ma'am. Yeah. Go ahead, please.
Okay.
గింజలు ఇస్తాడు అంతే ఇట్లా కొంచెం ఇట్లా తోవి గిట్ల గిట్ల అని
Yeah, ma'am. Anyone who like to go ahead?
Good evening, sir.
Yeah. Go ahead, Omkar.
Thank you so much, sir, for wonder. It was a wonderful session and watching continuously your session. I have one question for you, sir.
Okay.
Please suggest us for a simple RNN architecture and LSTM architecture programs for the beginners, like our students. I'm requesting you, please suggest me some programs so that I can implement and I can show for my students.
Yeah, okay. So I will try to give
See,
some
she
reference.
got
Okay, sir. Please give me some reference so that I can
now chat group is
refer.
not visible.
Because, sir, I am implementing the programs, but might be some compatibility version I'm not getting for in my system. So,
Okay.
please give me the source code so that I can execute.
I will share in the LMS. I'll try to share these links. Yeah.
Okay, sir. Thank you so
So
much.
there was some question Sonali Kharade ma'am was asking Rasa or ChatGPT. ChatGPT is better, but obviously there is a cost associated with it. So that's the reason. Yeah. Manju, thank you for your kind words. Yeah, Mutam ma'am, sir, you want to go ahead? Anyone who want to express themselves, guys? Any doubts, any questions as of now? Yeah, Rasa has a limited capability, but ChatGPT is a better version, so I would suggest ChatGPT because Rasa cannot handle that human language, right? That's the reason. Yeah, ma'am. Mangal, Lalita, ma'am, you can unmute yourself. Yeah, okay. Asfia ma'am, thank you. Thanks for your kind words. Hope you guys were able to understand the entire generative AI session, how to create a simple app using GenAI. This is what a new thing I have shown you guys. So hope the code and everything I will showcase you. I will also share this in the LMS along with the PPTs. So you guys will be able to follow it up, and maybe you can try doing this hands-on, okay? Books, you guys, there are multiple free courses available for the generative AI. Especially go for the deep learning, not deep learning. So what is this set? Course area has one more site, deeplearning.ai. So where you'll find various free courses as well. Gemini or ChatGPT. So it depends, guys. ChatGPT is still better than Gemini, but yeah, Rajeshri ma'am. Yes, I will share this in LMS. Okay, everything will be shared with the Amar today, OD, and then they will upload it. All right, guys. So thank you very much. It was a nice session. So see you in next session. Okay, I will leave. If I have any doubts, Amar will take it from here. Thank you, Amar.
Thank you, sir. Thank you very much.
Yeah, thank you.
Yeah, thank you so much. So dear participant, I just shared the attendance link in the chat box. So please mark your attendance and share your feedback as well. And coming to the certification part, so those who attended 60 and more than 60% of the session, they will receive the certificate within 7 to 8 working days. Whatever the material, recordings, the code, whatever is there, whatever we took in the session, definitely it will be there over the LMS. Now, if you have any query or question, please let me know. Attendance link, please. Yes, just I shared. What is the LMS? LMS is a learning management system, and by using the LMS, we are providing you the recordings of the session, then material, assignments, and attendance. Miss throughout the join through the class. I didn't get you. Sir, I didn't find the material from the LMS. We'll upload that. Today's, as we're done with the program, we'll upload that within like, if so said, by today end of the day, it will be there. Great session, sir. Thank you. I couldn't get link of LMS. Omkar, you can drop an email to edl@xla.com when we can expect the certificate. Yeah, so Swara, as I informed that, if your attendance is 60 or more than 60%, you will receive your certificate within 7 to 8 working days. 1 minute. Miss attendance form, sir. You have to mark your attendance. How do we access the LMS? We covered that in the first session. You can go through the day one recording via YouTube. Can you please provide the LMS link in the chat? So LMS link means be like it's LMS URL. It's onlinelearning.xlr.com. Thanks for arranging such a informative activity. Welcome. Let me check the comment over the YouTube. Okay, all good. Anything else, guys? Yes, after 7 8 days, if you feel that, sorry.
Good evening, sir.
Yes, very good evening.
Sir, where can I get the LMS link, please?
So LMS link means it's LMS URL and its URL is onlinelearning.xlr.com. Onlinelearning.xlr.com. I will share that in the chat box.
Okay, kindly share it, sir. Thank you.
Yeah, sure. Yes, I'm sharing that. Sir, will certificate be sent to our email ID? Yes. So I would like to explain one more time. If your attendance is 60 and more than 60%, you will receive a certificate of participation within 7 to 8 working days via registered email ID. And after 7-8 days, if you feel that, yes, my attendance is more than 60%, but I am not received the certificate, feel free to reach out us at edl@xlr.com. Please share the attendance power failure. Okay, yeah, I'm sharing the attendance one more time. Just a minute. Sir, I'm not in the group. No problem. You can drop an email to edl@xlr.com. We'll help you on the same. Whatever your queries or question, definitely we'll figure it out. We'll check from the backend if the queries regarding to the LMS, material, recordings, anything. Okay, I think so. We're good to conclude. So thank you so much for making this faculty development program successful, and definitely we'll arrange such kind of the FDPs in the future and will share you the notification via WhatsApp groups or email. So once again, thank you so much and bye bye. Take care of yourself and take care of your family.